Hello, Terry. Thanks for the introduction, and hello, everybody. I'm pleased to see so many of you on the line. And my expectations, those who are on the call today and will be watching this recording later, are deploying Ignite in cloud environments or planning to do so. And as part of that deployment strategy, you might be considering to use, let's say, serverless code, serverless functions. And the tricky question is, what are the best practices for the usage of the serverless functions together with Apache Ignite? And that's actually the primary goal of today's session and conversations. I did some research and I decided to put together some kind of guidelines and some suggestions for you, so that whenever you start, deploying your Apache Ignite clusters in any cloud environment, and then you would have serverless functions connecting to that cluster, you will know what are the best ways to interact from the serverless code with your Ignite shared system. All right, let's move forward. What's the agenda for today? First thing first, let's remind ourselves what the primary profit and benefit of serverless computing. And especially in that section, I would try to show how Ignite is, how you can benefit with Ignite and when it comes to the serverless computing. After that, I think that when it comes to the serverless code, you remember that you usually pay for the execution time. You're paying for the resources your serverless function consumes while it's running. And before you can run that function, you need to start it, which means that once the function is started, it also needs to connect to, let's say, your Ignite cluster. And they will be checking various connectivity options, like which one to use and when, depending on your serverless code, let's say traffic and how your serverless function is supposed to be used. Then we will take a pause, at least you. I would actually be showing you some quick demo. I already have a provisioned Ignite cluster in a cloud environment, and then we will be doing a live coding. I will show you how to quickly create a serverless function, deploy it in the cloud, and then do some, useful operations with it. And then we will conclude and finish the session by discussing a little bit different but adjacent aspect of, like, what are the let's say Ignite cluster deployment options in the cloud. What should you consider? Do you need to deploy your cluster in let's say in virtual machines or Kubernetes, or should you go for the managed service? We will keep some time for that conversation. All right, serverless computing with Apache Ignite. What's the profit, or what are the benefits? Regardless of all the fancy marketing promises, the primary objective of serverless computing is cost savings. Because nowadays, I think that we pretty much understood the need of microservices architectures in comparison to monolithic applications. But the thing, and one of the issues with microservices, is that those microservices should be up and running all the times. But also, you might not be using any particular microservice all the time. But like, as long as that instance of a microservice is running, you're paying for it. You're kind of signing a check to a cloud provider. And the thing with serverless computing is that the guys decided to come up with some, approach where you will be paid, you will be charged and billed only for the amount of time your serverless code is executing. And that's how we can achieve some cost savings. So what it means, let's say that to the right, you see a chart that shows that you have some serverless function running and the traffic is inconsistent. Actually, the traffic is pretty low. Let's say at 5 a.m., you've got only like 25 requests to your functions. Then at 5 a.m. and 1 minute, you kind of had around 12 requests. Then at around 5:03, you have any request to this function. And the good thing is that you will be paying only when the function is being actually used. And how are we charged? Like, what are we paying for? Every cloud provider charges us for request count. And then what's more important, they charge us for the function execution duration. For instance, you might have 25 requests that hit your serverless function within a minute, but all those requests were executed within, let's say, like 100 milliseconds. But at the same time, if you have the same like 25 requests and they within a minute, but it takes you like, let's say, 5 seconds to execute every request, obviously you'll be paying more. And in addition to the requests count and function execution duration, you will be paying so-called implicit costs, because usually every cloud provider has a managed service group that is sitting and monitoring your serverless code, scales that function, and makes sure that your serverless function can digest and process ever-growing traffic. And right now, let's focus on the function execution duration, because that's exactly the area where Ignite as an in-memory database can help you to expedite the things and help you to reduce cost further. Or at the same time, if you don't configure, don't connect to Ignite properly from your serverless code, you can negatively impact your function execution time, which means that you will be paying more. All right. So the duration, I would probably follow this simple formula and assume that the function execution duration can be split into two primary parameters. First, startup time. Before your function can be used, your serverless environment has to load it and make it available for the execution. And once that function is loaded, the logic execution starts. And we can go further and split that logic execution into another two parameters. The first one is local logic execution time, which means that your function is just, some like small piece of application that executes locally, and that execution time accounts into the total execution time. But at the same time, your serverless function, when it comes to the remote logic execution time, your serverless function will not be living in a vacuum, which means that most likely it will connect to your backend system that is running in the same serverless environment, or it can go and connect to, let's say, a database that you also deploy in this cloud system. In any way, and that remote logic execution time most likely will contribute most to your total to your duration. And when it comes to Apache Ignite, usually if you provision a reasonable Apache Ignite cluster, if the cluster is optimized, Ignite can accelerate there and decrease the remote logic execution time parameter, meaning that your duration of the function execution will be smaller and you will be paying less. But at the same time, Ignite goes with many connectivity options. We have thick clients in Ignite, we have thin clients, we have REST protocol, we have JDBC and ODBC drivers, and depending on the connectivity type you choose, your startup time can go up and down. And in the following section, we are going to review the primary connectivity options of Ignite, and I will share with you some suggestions on which one to go for with serverless applications. So Ignite connectivity options, which one to use and when. Let's talk about thick clients first, because I think that whenever you start with Ignite, that would be your default connectivity option. It's like it exists from the very beginning, and thick clients support all the capabilities, all the APIs you can find in Ignite. But as the title of this slide suggests, personally, I don't think that thick clients are the best choice for serverless functions. And let me explain why. If to compare thick clients to, let's say, thin clients or JDBC or ODBC drivers of Ignite, the startup time of your thick client or the connection time of your thick client from the serverless side to Ignite cluster will be the slowest. Why so that? Pay attention to the diagram on the right. When a thick client joins a cluster, it connects to one of the servers, and then the client sends a special join request. And then that joint request needs to traverse through the cluster topology. Every server node that you have in the cluster kind of must be notified about the fact that the client is joining. and then eventually at some point in time, the server the client is connected to will respond to the client saying that, all right, you are accepted to the cluster, and right now feel free to execute any operations. And the problem here is first that the client, when the client joins, it has to send a special message, and that message will be sending from one server to another, and the client will be waiting, while every server becomes aware of it. And another issue is that the more servers you have, the longer will be the startup time of your thick client. So for instance, if the thick client joins a 4-node cluster, probably it will be one time. If the client joins, let's say, 100 nodes cluster, the connection time to the cluster will be longer, because in that time, in that case, that join request message has to get to every to all the 100 servers. And that's about Java, but and .NET is simple plus. But if you're a .NET or C# or C++ developer, you also know that we have a version of thick clients available for those programming languages, and those clients will have another issue that will impact the performance of the startup time. Is because when you start, let's say, when you connect with a .NET thick client, that one starts a GVM internally, and you will be waiting also while Java virtual machine is started. So that's probably not the best thing you want to have in your serverless code. But if to look at this from a different perspective and ask the question such as, are there any usage scenarios when it makes sense to use thick clients? And I would say that yes. Let's say that you have some function and you have some consistent traffic that reaches this function. The traffic is low, like it's shown on this chart. Let's say we have around between 7 and 2 requests every minute, which means that the function was loaded once by your cloud environment, and the cloud environment does not unload it. And which means that let's say at some point in time, probably at 5 a.m., what we see on the chart, the function was loaded for the first time by the cloud environment, and then we kept using the same function that was already in the memory, and maybe paying, some fraction. We were paying for all those resources that was consumed by it. Another reason why you might want to use this client is that if you need any API that is not supported by another connectivity option or another type of client that we are going to review next. For instance, if you need machine learning APIs or if you need continuous queries, then you don't have any other choice but to use thick clients. Anyway, if you have a true reason for using thick clients from your serverless code, then also don't forget to enable TCP communication SPI force client to server connections property. You need to set it to true. That's a special new property that actually allows to start the function in such a way that the servers will never be trying to connect to their function. The function always will be connecting to the servers, and there is a special communication mechanism that will be used in such scenario. Those of you who are interested, you can just Google you can find documentation page that explains how this works. And also one of our Ignite committers and contributors was presenting at our virtual Apache Ignite meetup, telling more details of how this mode operates and how you're supposed to use it. Just keep in mind that you need it if you are using Ignite thick clients from your serverless code. Okay, that was the first one, the first connectivity option. And let's now talk about an alternate one, which is thin client. And again, as the title, as the subtitle suggests, I would recommend to consider this client as a default connectivity and option for your serverless functions. Why so that? Because generally the startup time is fast. At least it will be faster in comparison to the thick clients. And it also will it will not be the different. It will not matter how many nodes, server nodes you have in your cluster, whether you're connecting, let's say, to 4-node cluster or to 100-node cluster, the connection time will be the same. While in case with the thick clients, the connection time will be longer if you're connecting to, let's say, to a 100-node cluster in comparison to a 4-node cluster. How the connection works generally, as you can see on their slide, an application will connect to one of your servers that which address you provide in your configuration, and then that server will be used as a proxy server. So generally, most of the queries will be going through the proxy server, but there is one possible optimizations. The latest versions of the thin clients support so-called partition awareness mode, which allows your applications what that mode does. Once your application, let's say, connects to the cluster via that proxy server, then with the partition awareness feature, it can open a direct connection with any other server. For instance, if it needs to, let's say, get or update a record that is stored on another server, and that will help you to kind of to avoid any, let's say, communication through the proxy server when your client can always go directly to the node that keeps a primary copy of the data. Also, when it comes, let's say, to other programming languages, like in many occasions we are talking about Java, but when it comes to .NET, Python, Node.js, etc., thin client is based on the cross-platform protocol. We call it binary protocol. And generally, all the protocol is lightweight implementations. You can easily create any implementation for any programming language, and it will be high performant, and you always will be able to easily connect from your serverless function. It can be written in Java, .NET, or any other programming language, and use all the APIs that are supported by their protocol and by the thin clients. So right now, out of the box, those of you who are not aware of this feature, thin clients, the community and GridGain we support. We provide clients for Java, .NET, Python, Node.js, PHP. I know that there are some of the implementations for Go, for Rust, etc. You just can Google for them. If anything is missing, or you'd like to enhance any existing implementation, you always can go ahead and update, create your version, or update the existing client, implementing new features of their binary protocol. And surprisingly, like I think that we released the very first version of a thin client for Java and .NET many years ago, like 2 years or if not 3. And those days we were not considering that the thin client would become so feature rich. Because right now, let's say when it comes to Ignite 2.8, thin clients and the underlying protocol already support SQL, key value APIs, and transactions. In Ignite 2.9 release that was published and officially announced a couple of days ago, we added support for compute services and clustering APIs. And already Ignite 2.10 is being planned, but we already implemented continuous queries APIs. If I'm not mistaken, that feature will be available for .NET and Java. Some of the features such as transactions or services are not available, are not implemented for Python or Node.js yet, but it's like, go ahead and do this, or come to the community and vote up that you would like to have that API added to one of the clients. And finally, generally, I think that for 99 or 98% of the use cases, the thin client would be sufficient as your primary connectivity option from your serverless code. But also there is one usage scenario when you might need to fall back to Ignite REST protocol. And you would probably switch to it if you need to generate a Graal VM native image for your serverless function. So generally, again, if to compare the startup time, because right now we are primarily comparing the startup time between thick clients, thin clients, and the REST protocol. I would bet that the startup time, or like connection time of the REST protocol would be identical to the thin client one, because generally what you see on this picture, every cluster node, every server node of Ignite when you enable this protocol, it will deploy an instance of Jetty server. And whenever you are trying to, let's say, to execute a cache get request or SQL operation using this protocol, then Ignite will be just opening an HTTP connection. Your serverless function will be opening an HTTP connection with one of the Jetty servers running on one of these nodes. And again, as it's said in the title, just consider this option if you need to generate Graal VM native image. Speaking about the Graal VM native image support across cloud vendors, I would say that, if I'm not mistaken, AWS should already support this feature so that you can generate a native image for your serverless functions. When it comes to Microsoft Azure, I'm not sure. When I was checking this info like a month ago, it was said that Graal, it's probably impossible or just hard to generate the Graal VM native image for your Microsoft Azure functions. But I might be mistaken, or things might have changed since that time. And when it comes, let's say, to the Graal VM native image support for other connectivity options like thick clients or thin clients, those are planned and those will be supported in foreseeable future. So like the REST protocol is just something you should use if like you cannot wait and you already generating Graal VM native images and you want to connect to your Ignite cluster. Okay, and just as a reminder, if you are enabling and want to use Ignite REST protocol, don't forget to enable this module in your Apache Ignite Maven configuration, or just add this library to your class path when you're starting your server nodes. All right, let's try to summarize and let's try to recap on the connectivity options when it comes to the serverless environments. So generally, as I said, consider thin clients, and as a result, Ignite JDBC and ODBC as probably the primary and default option if you need to connect from your serverless code to your Ignite cluster. Because the assumption, again, why I'm saying that? Because the assumption is that your serverless function will not be running for a while. Most likely, you would start the serverless function, it would work for a minute or so, and then you just need to shut down this function. And that's why this the time it takes for your serverless function to connect to your Ignite cluster truly matters, because it would influence the duration, the total duration of your function execution. And at the same time, as I said, REST API is that for Graal VM if you need Graal VM native image support. And as for the thick clients, again, fall back to those thick clients if you need any feature that is not supported by thin clients yet, or if your traffic, if a traffic to a serverless function is relatively consistent and your function is not being unloaded by a cloud environment frequently. As far as I remember, when it comes to AWS, Amazon keeps your function loaded for 5 minutes. So like it will unload your function if there is no any single request during the last 5 minutes. So probably that will be not a big deal. That will be not a big deal for you. All right. So another question that I frequently hear is that how all this related to Micronaut, Quarkus, and all other frameworks that are support serverless environments. So here is again, when it comes, regardless, we have integrations with some of these frameworks. We have an official integration with Micronaut that was contributed to, that has been contributed recently. We support Spring Boot and Spring ecosystem historically, but nevertheless, whether we provide any official integration for a framework or there is nothing yet, even with the integration, the integration always uses some type of connectivity to the Ignite cluster that we discussed before. For instance, when it comes to Micronaut, if you decide to use Micronaut for your serverless function and you need to connect from Micronaut to, let's say, your Ignite cluster, then when you will be setting up Ignite Micronaut integration, don't forget to tell this integration to use thin clients, because those can boast about faster startup time. All right. All right, and now let's do the demo. I think that was eventually the primary. So those were the primary suggestions I wanted to share with you. And right now with the demo, let's just relax and try to build our very first Ignite serverless function that will be connecting to Ignite cluster, and we'll do some operations there. So talking about their demo setup, I already have an Ignite cluster provisioned in Microsoft Azure. That's a 2-node cluster. I loaded a world database there. That database keeps a list of all the countries and all the cities of those countries. And the goal for the function, we want to create a function that would process HTTP requests and would return the most populated cities based on the population that you're providing. For instance, if you want to see what are the list of the population, the list of the cities with population bigger than 8 million, the function has to return that list. Or you can request another population, and the function has to process that request and give you a valid list of the cities. All right. While I'm showing this demo, guys, I would encourage you to use the questions tab. Go ahead and ask your questions, because once we finish with the demo, I will be fully yours to address anything that was not covered in this presentation. Okay, so let's do this. I'm clearing this screen and let me show you where my cluster is deployed. As I said, everything is running in Microsoft Azure. I deployed everything in Kubernetes. All the server nodes are there. I started this cluster yesterday. And right now, let me connect. Also, I know that there is a special service, Kubernetes service running, and I would use this service to connect as a connection point from my serverless function. So I need to know the external IP address. That's the address of my function. And now let me show you how the database looks like, because as I said, I preloaded a city database into that cluster. So for that, I downloaded the latest Apache Ignite release. And I want to connect to the cluster using SQLine tool that is shipped with every Ignite distribution. We are using JDBC driver, Ignite thing, and we need to use this external IP address. Okay, what happened right now? I connected from my local laptop to the Apache Ignite cluster that is deployed in Microsoft Azure. And here is I have some tables. There are some system tables, but these are the tables that are created beforehand, and that's our world database. So you can see, for instance, let's execute this query because, for instance, I want to return, select name, population, country code from city, where population, let's say, is equals to 8 million. And I want to order by population in the descending order. Okay, something is wrong. Where population, no, not equals, is bigger, is equal or bigger than, right? Is equal, state, select name. All right, that's that proper syntax. All right, that's these are the cities. So generally, Mumbai, Seoul, São Paulo are the top 3 most populated cities. And what I want to do next, I want to create a serverless function that actually would be answering this question. I, as a user, would exit this function and ask, give me a list of the cities with population bigger than something, right? And actually the function, all the function needs to do, the function has to connect to the cluster and execute this query. Let's do that. I will open another tab. Let me just go to the downloads folder, create a directory there. Let's call it Azure Demo. You're going inside. And right now I will be using Maven to generate the artifacts. Let me use this command. I will just copy and paste it so that we don't wait while I'm typing everything in. So what this command does, we will create the project. That would be their group ID, and that's the artifact. That's a special artifact that is supported by Microsoft, and it will generate all the required files and templates. And also here is one important parameter. The Java version has to be 8. To my knowledge, up to this point, Microsoft Azure does not, like if you want to run your serverless functions, you cannot use Java 11 or anything that is bigger than Java 8. So that's why you have to use Java version 8. All right, generating this project. All right, let's fill in some the default parameters. Ignite demo, group ID, let it be Ignite demo as well. Version, let it be version 1.0. Package name, let it be demo. And we are asked to validate everything. So far, so good. The project is generated. Let me check it out. That's a standard Maven project. Palm XML file, source code, etc. Let me go ahead and open it with IntelliJ IDEA. It's in downloads, Azure Demo, Ignite Demo. That's the project. And here is what I like this template provided by Microsoft, that you have everything, pretty much everything you need to start if you are building a serverless function. Here is, if you explore the source folder, we have demo, we have functions, some template. Actually, you can right now go ahead and deploy this to the cloud and do something, but we will be editing and modifying this code. So first thing first, we are going to, our serverless function has to connect to the Ignite cluster. That's why let's add the following dependency. That will be our Apache. We are adding our Apache Ignite. We need Ignite core artifact. We will be using Ignite Thin Client. That's why Ignite core is more than enough. And if I'm not mistaken, I'm running Ignite with version 2.8 on the cloud, on this cloud side. That's why I will use the same version in here. Good. So let me ask Maven to import all the changes. All right. Well done. And next, let's update our function. Let me create Ignite client reference. Ignite client, that's a reference you use for your thin clients. I'm keeping it at the class level because it might happen that this function will be loaded once and then that function will stay loaded for some time, so that it will be processing more than one request, and I don't want to initialize this connection every time the function will be executing this run. We will initialize it only once. Okay, so here, as you remember, our function has to process the request returning all the cities with a population bigger than something. That's why we are expecting users to provide the population value. That's the parameter, and let me rename this variable to population. So what happens if the population is not provided? Then the function will respond with this error message. So far, so good. That's handled. But if the otherwise, let's create a client configuration. If Ignite client is not initialized. Right now, I'm not paying attention to all those, synchronization principles, but generally you need to use a synchronized block or volatile variable, like at least volatile variable for this one to ensure that everything stays consistent and complies with Java memory model. New client configuration. And my address was, what was my address of the function? Remind me. That's how I can connect to the Kubernetes cluster. That's the address, and the port numbers. I remember the default port number, which is 10,800. The only one issue is that I need to do it this way, set address. Good. And finally, let's initialize our client. We are saying that we are using ignition set, and I'm starting client using this configuration. Once the client is started, we need to execute the request over the cluster, and let's see how that request looks like. Let me copy it from here. I don't want to type it twice. So we are going to use Ignite SQL fields queries interface. SQL query, and I'm saying that's what I want you to do, except for the population will be provided. So we need to then say use the value of a set argument. We need to instruct to use the value of the population that was passed into this function. And also, I know that this table is deployed in the public schema, and I want to set this schema in here. All right. Once we do this, we actually can execute this query, and then we can prepare a result. I don't want, the rest of the stuff is not that interesting, so let me copy and paste this code snippet from my notes. Generally, that's what happens. Next, we will execute this query using Ignite client. We are connected to the cluster. And after that, we are using string builder, to prepare something in a nicely looking fashion. So we will create the table with results. And finally, let's respond here. We need to return this list builder to string. All right, that's it. The function is ready. And let's now go ahead and do the following. I want to build this function, but before I deploy this function in the cloud, I can deploy an instance of this function and validate everything locally. So there is a special support provided by Microsoft. So to do that, first let me see what's my Java version, because yeah, serverless functions support only Java 8. Let me see. I should have Java 8 installed on my system. So let me switch to it. I'm using Zulu. Yep, that's the version. Okay. Let me use that Zulu. And right now, if I check, yeah, the Java version is 8. So far, so good. And the next step is let's build this code, Maven clean package. I don't want to run any tests. Building. Okay, the project is ready. And as I said, before deploying anything into the cloud, we can validate everything locally. So to do that, we need to use the following command, Maven Azure functions run. And that command will kind of deploy a serverless, in quotes, environment on your local laptop. Okay, that's the function. Let me copy this one. I will be using curl dress what's wrong with you? I stopped it accidentally. Let me restart it back again. All right. If I run it, if I don't provide any response, it said that you have to set the population. And let's do this. So let's return all the cities with the population equal or bigger than 8 million. All right. Where is my return? The result. Why don't I see the return? Builder. Builder to string. Okay, that's weird. I should have seen something. Let's check me the output. There is an exception caused by Ignite. Ignite failed to process request. Syntax error. Where is this exception? Looks like yes, that we need to fix this function. That's interesting. So let me find this exception. Select name, population, country code from city where population is. All right. Let's do this. That's the mistake. Okay. That's why we need to have such feature available in for our development environments. Let me quickly rebuild everything, and then I will run this thing locally. Okay, good. And fingers crossed. Good. We fixed the query. How about 5 millions? All the cities with population bigger than 5 millions, we are getting more cities. Okay, and let's do the final thing. So right now, we tested, everything works fine in our development environment. And right now I want to deploy everything. To do that, I'm using Azure Functions deploy command. And that will take time. So I think we have exactly 5 minutes left, and probably during that time, the Azure will be able to finish this deployment step. And while we are waiting, let me go back to the slides and quickly share some thoughts on the Ignite cluster deployment options. Because in this case, for instance, with my demo setup today, I provisioned and managing my cluster that was created for demo purpose, and I'm using Kubernetes. And one of the most frequent questions that people are kind of asking is, what should we use if we decide to use Ignite in the cloud? Should we go for and deploy Ignite server nodes, the database, in virtual machines, or should we use Kubernetes? And here is, I would say that we don't have any strict recipe. It depends on the needs and on the practices in your company. For instance, we have many GridGain customers who have a rule when all the databases, let it be Oracle, Postgres, Ignite, or Cassandra, will be deployed on virtual machines, and the applications can be deployed in Kubernetes. At the same time, we have other customers who deploy everything in Kubernetes, including Ignite server nodes, the database, which is why, what's your general practice? Because for us, it really doesn't matter. For sure, it will depend, you need to do some extra steps and extra preparations when you're deploying your server nodes in your Kubernetes environment. With virtual machines, it might be more simpler. But rather than that, everything is possible, and it's up to you to decide what to use. It's primarily because you will be doing that self-service. You will be handling, you will be upgrading your clusters, you will be provisioning, you will be scaling. You have to care about that. At the same time, if you are looking for Ignite Managed Service option, it exists. My company I'm working for, GridGain, does it for Ignite. We donated Ignite to the foundation. We are still one of the major contributors to the project. And why is it related to this conversation? Because when we are talking about serverless functions is an excellent example of a managed service offering. Yes, you're just creating a serverless function. The serverless function gets deployed, and that's it. After that, the serverless function will be managed, loaded, and then scaled out, scaled in by a group of people, by a managed service group. And that everything happens behind the scene. And the same with your Ignite or like GridGain cluster. If you need this level of service and support, you always can let GridGain to deploy and provision your Ignite servers, and then you just can go ahead and create your code, deploy this code, and everything will work together as a shard. Okay. Wrapping up. So as for the additional resources, the demo that I was showing you today is based on the tutorial that is available on the GridGain documentation portal. So just go ahead and find it. It's called Ignite Serverless Functions for Azure. Also, if you want to do something with Micronaut, if you're using Micronaut for serverless use cases or microservices, we also have tutorial for you. And if you are new to the serverless architecture, so you would like to see what are the implications, what are the benefits, what are the shortcomings, or let's say disadvantages, I would recommend you to check this serverless architecture deep dive, this resource that explains all the pros and cons, because sometimes probably you might be oversold the idea of serverless functions, and you might deploy the serverless functions, but they will be running all the times, not optimized, and you will be paying much more than you would pay if you would basically run a monolithic application or a set of microservices. So check this resource as well. I truly liked it. So, and also, like, feel for sure don't miss any other presentations we are related to Ignite today. And what happens after the summit finishes. We are running an Apache Ignite virtual meetup, and there are already a lot of interesting meetings and sessions. Community comes there, users come here, share their user stories, best practices, etc. Sign up and watch for updates. All right, Terry, I'm done. So if you have any questions, I'm ready to address. And while I'm addressing the questions, let me also see how we are going with the deployment of the function. So the function is deployed. And do you have any questions?
Yeah, thanks, Denis. Again, if you do have questions, please put them in the questions box. We're almost out of time here. First question is, says, my understanding is the thin client doesn't allow for concurrency as well as the thick client. For a serverless function, I suspect concurrency doesn't matter since it gets born, runs once, and dies. Is that correct?
Generally, yes. And I mean, like when it comes to this usage concept that you would launch this serverless function, it will be used, and then it will be unloaded. That's true. But at the same time, the thin client is thread safe, meaning that you can use a single instance of the client and share it across your threads. So generally, I did not hear about any like thread safety related issues. So it's like it's concurrent. At least, probably, at least that's a good actually question to double check. I'm 100% certain that client is thread safe, but whether it's concurrent or not, we can quickly double check with the community.
Okay, good. We're actually at the end of time. So thanks everybody for attending this session. The next sessions will start in 10 minutes. Thanks, Denis. Have a good day, everyone.